With quadratics, we have some equivalent statements, basically, we can say about solutions. And then depending on how you're talking about them is kind of how you use them. A little confusing, I know, but here's what I mean. Okay, so if we have a quadratic, you can see the graph of this quadratic here, x squared minus x minus 12. Basically, there are some important points about where it hits the x-axis. It says x minus p is a factor of the quadratic expression. Okay, x minus p. If we write it in factored form, x minus 4, look at where it's hitting the x-axis at 4, x plus 3, look where it's hitting the y-axis at negative 3. Just knowing these two things, we could write the factors. X equals p is a solution. Well, okay, so we're talking about being a factor. Okay, if we know it hits the x-axis at negative 3 and 4, we can write it as x minus a negative 3, or keep change, x plus 3, and x minus 4. So we know those are factors. If we know it hits the x-axis at negative 3 and 4, then those are our solutions. X equals 4, x equals negative 3. We also know that if our solutions are 4 and negative 3, then those are our x-intercepts. 4 and negative 3 are x-intercepts. Notice we basically said the same thing over and over and over. It's just how we talk about them. Factors, solutions, and x-intercepts. The solution to your quadratic is where it hits the x-axis. So if I had this equation here and I typed it into the quadratic formula, I would get x equals 4 and x equals negative 3. The solutions are where it hits the x-axis. Where it hits the x-axis, or where the solutions are, we can use that to write our factors. We use this x minus p. We say p, but it's really whatever the solution is, like I did here. If it's a negative 3, we plug negative 3 in. If it's a 4, we plug 4 in. So factors, solutions, x-intercepts, they're all basically meaning the same thing. You just use whatever part you need to. If I'm looking at this graph and I want to write the factors, that's how I'm going to write them. If I'm looking at this graph and I want to know what the solutions are, well, it's where it hits the x-axis. If I want to ask you where is it hitting the x-axis, it's going to be the same thing as solutions. So that's what we mean. They're equivalent statements, just take it in different contexts. This idea, though, can help us graph. Let's look at an example. It says sketch the graph of y equals x minus 4, x plus 2. Remember, x minus p is a factor. So what this tells us is where our x-axis, or where our x-intercepts are. So x has to equal 4, or 4 has to be an x-intercept. And then right here, remember, we can write this as x minus a negative 2. So our other solution is x equals negative 2. So we know in factored form that it is going to hit the x-axis, this, since it's, if we were to multiply this out, it'd be a quadratic, it's going to hit it, the x-axis, at 4 and negative 2. But that's not enough to draw a parabola. Remember, we also use this formula, negative b over 2a. Now, to do negative b over 2a, you kind of have to multiply this out. So if I have x minus 4 times x plus 2, just using FOIL real quick. First, outside, inside, last. Okay, and when you use FOIL, your middle two terms are always your like terms. Okay, so our negative b is your negative 2, over 2 times a, well, a is just 1. So a negative negative 2 is positive 2. 2 times 1 is 2. Now, what does this negative b over 2a tells us? This is the x-coordinate of our vertex. We have a point at the vertex. It's an x and it's a y. This tells us that the x is going to happen at 1. How do we find out the y? We'll just plug it in right here. So I know that x equals 1. So I'm going to say 1 squared, plug it into this formula here, minus 2 times 1 minus 8. 1 squared is 1, minus 2 times 1, which is 2. minus 8. Don't know the reason. Sorry for that parenthesis there. 1 minus 2 is a negative 1, minus 8 is going to be a negative 9. So now we have a vertex. This is positive, so we know it's opening up, and we have where it's going to hit the x-axis. So let's sketch a graph. 1, negative 9. Okay, so if we look at your graph here, I'm going to sketch a point 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know it opens up because this is positive, and I'm going to sketch the points, the x-intercepts, for negative 2. 1, 2, 3, 4, and negative 2. And what I can do, and now we can always add more points in, making an input-output table, but if I just wanted a rough sketch, and it will be rough because, you know, I'm not very good at this. So there is a very rough sketch of our parabola. And what we did, remember, ladies and gentlemen, is we were able to find our y-intercepts, our x-intercepts. We were able to use this formula to find the x value of our vertex, plug the x value of vertex in to find the y value, and that gave us enough to draw a sketch of a parabola for this equation here. Okay, so don't get confused by all of these. Understand that they mean the same thing. If we know our solutions, we can write factors. X minus p. So we just put in whatever our solution is right here. Our solution also tells us where the x-intercepts are. So if I know what the solution is, I just plug them on the x-axis. Likewise, if I know what the x-intercepts are, I know that those are my solutions.